Hello everyone, I am A. Deepak Sharma from Department of Physics, Manipur University, and today I'm here to give my video presentation on the topic Structural, Optical and Dispersive Parameters of GDMN code of bismuth ferrite thin films. Here are the outlines of my video presentation. In the introduction, we all know that bismuth ferrite is one of the fascinating multiferroids that many researchers reported with enhanced electrical, magnetic, and optical properties in the last few decades. BFO has derived its much needed attentions among researchers due to its potential applications in storage devices, sensors, spintronics, photovoltaic device, controlled catalytic reactions, and optoelectronic devices. The ability to change or tune the oxidation state of Fe ion in VFO perovskites enable many researchers to engineer the optical bandgap, which is approximately around 2.7 reported in other literatures, and conductivity, thereby enhancing the photoferroelectric properties, and which makes the BFO a very prime candidate for the thin film solar cells. Incorporation of rare earth elements like gadolinium or samarium or transition element like manganese nickel into BFO perovskite structures would certainly change the oxygen vacancy and thereby affecting the optical properties of the BFO thin films. In this work, I have uh, fabricated BFO thin films with GD and MN DOF 5% each into the BFO lattice via sol gel processing technique onto chroning glass substrates. These are the experimental techniques in which bismuth nitrate and ferric nitrates are used as precursors, and gadolinium nitrate and manganese acetates were used as a doping precursors, which were mixed together to form a stock solution, which pH was maintained uh, correspondingly, and its molarity is at about 0.2 moles per liter. And from the stock solution, it was filtered through a nanofiber filter paper and was dripped into the spin cotters, which was spin at around 3000 rpm within 40 seconds. It was done cautiously to increase the spinning rate stepwise and finally form amorphous thin films. This amorphous thin films was annealed around at about 550 degrees centigrade for 2 hours in muffle furnace, and finally the annealed thin film is ready for characterization. At first, we take the XRD, which gives the XRD patterns in which actually in BFO, pure BFO thin films, there was two splitting peaks at around 32 degree, but this was merged into single peaks when it comes to BFO thin films co-doped with GD and MN. So there's a structural change towards tetragonal phase or rhombohedric structures from the rhombohedral structures, orthorhombic or tetragonal structures. I have also calculated texture coefficients, which was of these two major peaks, and texture coefficient of 110 is very much larger than that of 101, indicating its preferential uh, orientation along 110 plane. And the crystallite sizes and microstrain calculated from WS plot, Williamson-Hall's plot, was reported here and found to be about 20 nanometers and about 0.0043. In the Raman studies, we from the group theory, we know that there would be 13 Raman active modes, and it is well known that lower frequency modes below 167 correspond to bismuth ion bonds, and higher frequency corresponds to ferric or iron oxygen bond vibration. As evident from the figure, there's a subtle increase in E7 mode in the vicinity of 470 centimeter inverse in this film, and this would certainly affect the oxygen vacancy in the lattice structures. There are also a huge peak in the B mode appearing at about 625.5 centimeter inverse, suggesting existence of tetragonal phase with P4MM space groups, which is changed from rhombohedral as we incorporate gadolinium or manganese in these thin films. And AFM studies reveals that there's a dense films deposited onto the glass substrate, and its grain size is about 90 nanometers, which is quite large than that of the crystallite size, indicating the existence of polycrystalline thin films consisting of many crystallite in its grain. Here, this is the FECM images, and this also shows that it's a uniformly distributed thin films, and the cross-sectional view gives the thickness as well as the multi-layer structures could be seen. Layer by layer structures of thin films could be seen from this cross-sectional view. EDX analysis gives the pics of GD, MN, so therefore incorporation of GD was also confirmed from this EDX spectrum. And in the optical studies, the rightmost one is transmittance curves, and we find some two peaks. So therefore, we could apply the Swain-Paul method or envelope method so that the refractive indices and the real part of the dielectric constant emergent part could be calculated using the formula correspondingly. And as seen from the figure, there's a peak-like structures in uh, around about 800 nanometers in both refractive indexes and real part of this uh, dielectric constant, and the lowest part, I mean the extinction coefficient and the imaginary part also follow the same pattern as evident from this figure. And the main part of the optical studies is to determine the optical band gap, which was calculated from the Tau's plot by linearly extrapolating the linear region, and is found to be about 2.62 electron volt. And I have calculated another parameters known as NER or near edge absorption ratio, which was calculated using the relation here given here, and it was found to be about 0.87, which approaches to 1, indicating that the Orbeck tail is substantial. As there is a significance of Orbeck tails, I have calculated the Orbeck's energy, and is found to be about 0.432 electron volt, and it is linear fitted, and here parameters are given here. And finally, have come to the conclusion of my work. Here, bismuth ferrite thin films with GD and Mn dopes are fabricated using sol gel processing technique via spin coater, and XRD confirms the raw material structures of BF4 ferrites with higher preferential orientation and 110 plane. And here also there is a many literature also report a tetragonal sieve from rhombohedral to tetragonal sieve bought in XRD and Raman confirms that, and Raman also concludes the incorporation of ZD and Mn at A and B side of the bismuth ferrite, as there are certain sieve of the corresponding peaks, and surface morphology deals with reveals the formation of dense layer by layer thin films onto chronic glass substrate. Transmittance spectra denotes the existence of multi-layer thin films deposited on to the substrate and showing high transmittance rates beyond visible range with the increase in wavelength. Optical band gap from Tau's plot and found to be slightly lesser compared to the pure BF4 thin films. NER or near edge absorption ratio of the films approaches the value of 1, indicating that Orbeck tail is substantial. Therefore, we have calculated the Orbeck's energy and found to be about 0.432 electron volt, which might be attributed due to lattice distortion incorporated with doping of GD and Mn. And finally, the ability to tune the optical band gap to slightly lower value, and with the incorporation of ZD and Mn would certainly find applications in optoelectronic devices and thin film solar cells. These are some of the references that I've used in the preparation of this video presentation, and thank you everyone for listening.